Hello and welcome to Pond's Python practice. Today I'm going to be talking about classes and object-oriented programming. The fundamental idea of object-oriented programming is that each thing in your program is an object that has its own attributes and functions attached to it. And you can then use these attributes and functions to quickly and concisely reference things rather than writing it all out at once. And I hope that some of you have tried to re-implement Pong using classes just to see how much easier it is. So I'm going to use this ping pong ball as an example. It's just a standard issue ping pong ball, so nothing too exciting about it, except that it makes a good candidate for a class. Okay, it's a ball. So we're going to call our class Ball with a big B, because that's the convention. So the first thing you do in a class is you define an initializer function. And, well, what does it need? Well, the ball's a sphere, and we're going to be drawing it as a circle, so it needs a radius. And we want to specify what color the ball is, so we'll do a color, and while some balls are bouncy, some aren't, that one definitely is. So we use bouncy, and we're also going to draw it, so we need a velocity and a position. And I just went through each time self.attribute that is going to be called equals read the thing from the initializer. I also defined some functions, and I'm going to put the paper there because we don't actually need to see the things in the initializer to get the idea, and I'll move that up so you guys can see. So it's a draw handler, and well, how is this okay? Well, this is actually a helper function because it's going to be called from the draw handler, and if it's not called, it doesn't do anything, so it's all okay that I called it draw. So what it does is it references itself and the canvas object, and yes, the canvas is an object. That's why you can have things like canvas.drawCircle. That's just referencing an internal function like these two here. So this draw handler, it draws a circle with some position, and it's referencing everything as self.thing. So the next thing is radius. It's self.rad, not radius, because remember we called the radius self.rad. And so then it updates the position like we did in Pong, and it checks if there's a top or bottom collision, and I didn't write that out. Then call self.bounce. Then self.bounce, if self.bouncy, so that means it's a bool, it negates the velocity, so it sends it up and down. And if it's not bouncy, it just leaves it at the bottom sitting there. So, okay, what about the rest of the program? Well, sorry about my sloppy handwriting. We're drawing, so obviously we import simple GUI. And then we say our ball is a ball class object, and it takes a radius, and well, the radius of this doesn't really matter because this is only the drawing thing, so we'll set it to 20 pixels. It's a white ball. It is bouncy, so bouncy equals true, and we're going to draw it initially at rest at the middle of the screen. So then, ignoring these for a minute, the draw function is just normal draw function, def draw with a canvas object, except it's not that simple. What would we want to do in the draw object? Well, draw function. Well, we'd want to say draw a circle representing the ball and update the velocity and check for collisions, but wait. I did all of that already. I did it in the draw function of the ball class. So if I don't drop my paper on the floor, I can call ball, because I have an object of ball, ball.draw canvas. Because remember, the draw function takes the canvas object as C, but that doesn't matter that there's a name difference because of the nature of functions. And that's all there is to it. It just calls the draw function at the internal timer. Now, the real power of this, though, is if you start adding more objects. So you can define a second tennis ball. Well, tennis ball. You can define a second ping pong ball, or you could define a tennis ball or something else. And then you can make a list of balls. And I wrote that over here because I didn't think about it until too late. You can write a list of balls, and then instead of just ball.draw, ball2.draw, you can put 4 ball in balls, ball.draw canvas, and then that'll just go through it, and assuming you don't have too many balls, you won't run into anything with a timeout.
Okay, so here that is all coded up. You can see it's the same initializer function, the same bounce function, and the same draw function, except I actually expanded the draw circle and the top and bottom collisions to have real code, and you'll note that it's all self.pause, self.radius, self.blah, blah, blah. And you see same ball creation there, and the same main draw function. And I also added some simple GUI stuff to create a frame so we can actually see this ball, and some buttons to either add or subtract 1 from the velocity. So we run the program and nothing's happening because remember the ball is initially at rest. But we can increase the velocity and it can bounce down, and we can actually get it going really fast, and you can make a game out of it to see if you can keep speeding it up or slowing it down. Anyways, like I said, the real power in this is if you have a lot of balls. So here, well, okay, let's change that one. So here I've got 4 balls. Each of them is a different color. Each of them has a different initial velocity, but they all have the same initial position. And then I stored them all in this list, and nothing happens. Why is that? Well, it's not enough to just create an object and know that you have draw handler up here. You have to actually call that draw handler. So I could do it out ball2.draw, but that's stupid because I've got all the balls and I'm doing the same thing except just changing the name. So I can do a list comprehension for ball in balls. That's my list for item in my list up here. I can indent that so it's in the for loop. I can call item.draw on the canvas, and that just does the same thing that writing all of them out would do. And you see different balls, different colors, all bouncing around, and we can still mess with the velocity of our original white ping pong ball. So I'd also like to talk about while loops. This is the code that I'm going to use, and I would now like to explain it on paper.
So, well, there's a while loop here, but why is there all of this math? Well, okay, let's think about what a while loop does. A while loop, it says, while this condition is true, do all of this, and then go through again, and if the condition is true, go through all of it, and then if the condition's it goes on until the condition is not true. So, I like math. It's one of my favorite subjects, so of course I'm doing an example with summation. Now, Actually, I hate summation. Riemann sums was my least favorite week of calculus. Or it would have been if I hadn't realized this trick with using while loops. So, the summation, it just goes from the bottom thing to the top thing, and each time it starts with the bottom and it evaluates this thing in here, and then it adds that to the rest of the results, so the results start at 0. So I claim that this equals 100. Okay, well, how do I prove that? So it values at 1, 2, 3, 4, up to 10. So 1 times 2 is 2, minus 1 is 1, 4 minus 1 is 3, then 5, 7, up to 19. And yeah, you're right, this is the first in odd numbers. The general form of summation, which I'm going to use in the loop, is the summation of f of x from I to n. So, obviously you're going to want to define your f of x and just have it return a single line, or if you have a really complicated function, you might want to go over multiple lines. Then you can go while I is less than or equal to n, because you go to the top thing and evaluate that too. And of course you want to define all of these things somewhere as globally. And then you just say your result for that time equals f of I. Then add result to the total and add 1 to I.
Back to the code now. This is the same loop that I just wrote out, except I concentrated the result and the total into just a plus equals thing. And I also chose to print I. And so we run it, and yeah, it does come up with 100. That calculation took less than a second, but it would have taken me maybe 2 or 3, maybe even as many as 5 minutes to write all of that out by hand, and even longer if there was more members. But say if we sum the first 100 numbers, then it still gets it instantly, but I'd have been working on it for a good 15 minutes, and I probably would have made at least one arithmetic error. So this loop, let's go through the hidden things. While condition, that just means that if this condition is true, then do stuff. Then another hidden statement at the end of the loop, end of loop. Check condition again, and if true, do stuff, then end of loop, then yeah. Goes on until the condition is not true. So, okay, this line here is a very important line. It increases the index, and that's the only way that this condition will not be true. Let's see what happens if I don't indent it. So I hit run, and nothing's happening, so we're just waiting for the while loop to get through, and oh, there's an error. Well, okay, it's printing I, but it's only ones for as far up as we care to go. And then it tells us that there's a time limit error, program exceeded runtime limit. Well, that makes sense because the condition, we don't increase I starts out less than n, so this may as well just be while true. But we can fix that by indenting it, and you can see that Python sort of wants that to be indented. So this also works for any number of them. So the first one, you'd expect that to be 1. First 2, 1 plus 3 is 4, and as far as you'd care to go. So good luck with your programs, and I will see you next time.